Welcome back to Holtham's Apiary. I'm Jason Holtham, and in this video, we're going to continue working on the do-it-yourself beehive scale. You won't want to miss it. Last time in the video, I showed you all the different components that I'm going to need for the scale. What I have here is I have some plywood that I'm going to put the load cells on each corner, and I've drilled a hole here in the middle so that the wires can go through to the other side where I'll have the HX711 module attached to the other side. All right, so I have them fastened down in place, and what I'm going to do next is, because I need to connect the four of them in a loop, I'm going to add to the ends here some DuPont connectors to make it a little bit easier for prototyping. Of course, I could just solder them together for now. That'd be a more permanent solution, but I think in the prototyping phase, I'm going to just connect them with some DuPont connectors. Okay, now I've made some DuPont connectors on all the ends here. I'm going to go ahead and connect the proper wires to each other. The way this setup is, there's 4 different load cells, and they all have a certain place where they need to be connected onto the HX711. So I marked those with tape. That's the E+. This one is the A+. This is the A-, and this one is the E-. And the way these get hooked up is that these two are connected together by their white cables. Then these two are connected by their black cables. These two are connected by their black cables. And these two are connected with their white cables. The red cables coming off from each one of these will go to its respective place on the HX711. And I will mark those red wires also with tape. So when I flip it over and the wires are going through the hole, I'll know where they belong on the amplifier module. All right, I have everything connected where it needs to be connected, and taped everything down just so that things don't fly back and forth the whole time while I'm flipping around, flipping the board over and such. So I've taped everything down. I marked the red connectors on the other side, so I know where to connect them on to the HX711. Now I've already, as I said, I marked all of these connector ends with their appropriate place where they need to go on the HX711. Here you can see that the top left is marked E+, then you have an E-, then you have an A-, an A+, a B-, and a B+ pin. The B- and B+ we won't be using, but the E+, E-, A-, and A+ we'll be using. And what I did was I also created some female to female DuPont connectors on a little jumper wire so that I can easily connect these wires to their appropriate headers. All right, those are wired up, and now I need to wire them into the Arduino, and then I'm going to have to go over to the laptop and start looking to see what kind of values are coming off of this load or off these load cells.
Okay, so I've got the Arduino hooked up to the module here. I have the ground and the VCC, the 5 volts, connected to the Arduino. Here's the Arduino over here, and I have the yellow pin is going into port 4. That's going to the data output on the HX711, and I have the clock, which is on, the clock is on pin 5. Okay, so what I've done is I've actually loaded into my IDE, I've loaded into the library that I need for the HX711 programming. So I'm going to go into examples, and then with examples I'm going to open up the calibration sketch. Now this calibration sketch is going to basically allow me to calibrate the module, and I'm just going to go ahead and I'm going to upload that to the Arduino, and then we can look in the serial monitor and see what kind of commands it's going to give us. Okay, to start calibration, place the load cell on a level stable surface, and it's level and stable. Remove any load applied to the load cell. Well, the load applied to the load cell is this board. Send T from serial monitor, set the tare offset. So let's go ahead and set the tare offset. Now place your known mass on the load cell. So I'm going to place this 1.25 kilogram weight on there, and I'm going to enter 1250.0. That's the weight in grams. So the new calibration value has been set to 21.3. Do I want to save this to EEPROM? Yes, I want to save it. And now on a loop, it is basically getting these values from the module, and yeah, looks pretty good. 1250, not bad, or close to 1250 anyway, with some minor fluctuations here and there, but it's pretty good. So now what I want to do though is I need to try something out. The use case for my hive scale is that I don't want the Arduino to be under constant power. I don't want to have to worry about having an external power supply running on the scale 24/7. I want to actually run it using a 9-volt battery. So I want to have some kind of a switch where I can turn it on and off. Now the problem with most of these scale setups is that when you have some kind of a switch and you turn off the power and then turn it back on again, then a tare function will happen. It will reset to 0, and I don't want that to happen. So what I'm going to do is I'm going to use this example sketch that's also provided by the library that will basically show me how to persist the 0 offset. Using the same pins, basically all the same information. However, I don't want to use this calibration value. This seems kind of random. And it's not even close to the 21 whatever I had. I'm going to uncomment this line, and that way I get from the EEPROM, I'll get the calibration value. I want it to initially tare, so I'm going to say this is true, and then I believe, because I was looking at this sketch earlier, I need to, right, if I send T to the serial monitor, then it's going to call this method, which basically sets the value into the EEPROM. So let me first of all remove the weight, and I'll upload this to the Arduino. Same thing here. I'll open the serial monitor. Error opening serial port COM6. Maybe we're looks like it's okay. Okay, so yeah, it's still pretty close to 0. Bounces back and forth a little bit. I'm not worried about grams. That's really not necessary for me. So I'm going to hit T, and it's calculating the tare offset. A very large value. Okay, so now we have the tare offset, and now to test it, I'm going to go back up here to the setup of this sketch, and I'm going to set this value back to false, because when I reset, I don't want it to re-tare. So I'm going to upload that, and of course I should still see the values that we saw before, approximately. Maybe, yeah, it's about the same, 1 gram here and there. And now I'll place my weight upon the scale. Pretty good numbers, pretty close. And I will reset the Arduino, and I expect when I restart it, and we'll see in the monitor, we'll see the starting text again, that when it starts again, it's going to be showing pretty much the same values, around 1250. So on the Arduino, there's a reset button. I'll hit the reset button, so that resets it. And we see starting and the output. And yeah, so basically this is the behavior that I expected. And I'm going to basically reuse most of this code here. And that way I'll be able to have a consistent display. Maybe it'll be varying by a few grams here and there. It doesn't really matter. But every time I switch it off, switch it back on again, I'll have values that are reasonable.
All right, that's it for this video. There was a lot going on in that video. I actually went back and I did solder together the black wires and the white wires because I noticed that the DuPont connectors were a little bit loose, and I was afraid that I wasn't going to get a good connection with those wires. So sometimes it's better just to solder it, then you know you have a nice connection instead of worrying about maybe some kind of a short circuit here or there. So I think in the next video what we'll do is we'll go ahead and add to that setup the OLED display so that we can get some nice numbers displayed, and then we can start thinking about how we want to design a housing for all the components, and try to get a working prototype that I can bring out to the apiary and do some field testing. If you haven't already done it, please hit subscribe, and I'll get new content out to you as soon as possible. As always, stay safe, stay healthy, and have fun beekeeping.